Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some choices feel harder than others, even when they seem pretty similar on paper, like picking a phone plan or deciding on an investment? Well, this new study dives deep into that feeling, and it turns out our brains might be making those decisions in a much more dynamic way than we thought. Today, we're talking about complexity and how it messes with our decision making, especially when it comes to choosing things that involve risk, like lotteries or financial investments. You see, most classic theories about how we make choices just focus on the potential outcomes and how likely they are. They don't really think about how much brain power it takes to figure all that stuff out. But this research says that the mental effort or complexity is actually a big deal. The researchers here proposed a cool idea. They think that when something is complex, it is like trying to hear a whisper in a noisy room. It takes longer to gather the information you need to make a decision, and you might make more mistakes or be less sure about your choice. They call this a reduced signal-to-noise ratio. And get this, they also think we're kind of aware of this. So, when faced with complexity, we might change how we decide, maybe by trying harder or by leaning towards simpler options if they're available. They tested this idea in 3 different experiments. In each experiment, people had to make choices between different options, like lotteries. The key was how they changed the complexity. Sometimes it was by having more possible outcomes, sometimes by making the numbers for those outcomes more complicated to calculate, and other times by making the probabilities themselves a bit of a puzzle. They always recorded not just what people chose, but also how long it took them to decide. In study 1, they played around with the number of outcomes in lotteries. Simple lotteries had just 2 outcomes, while complex ones had 7. They compared situations where people chose between 2 simple lotteries, 2 complex lotteries, or 1 simple and 1 complex. What they found was pretty consistent. When people had to choose between a simple option and a complex one, they usually went for the simpler one. This is what they call complexity aversion. It wasn't just about the potential money, but about the mental load. And importantly, it took them longer to make these choices when one of the options was complex. Now, when both options were equally complex, things got even more interesting. People took longer to decide compared to when both options were simple, and their choices were less consistent. This means they were more likely to make mistakes, or their choices didn't line up as neatly with the potential rewards. To understand why this was happening, they used a sophisticated mathematical model called the drift diffusion model. Think of it like this. Imagine a little ball rolling down a slope. The slope represents the evidence building up for a choice. The speed of the ball is like how quickly that evidence builds up. And the distance it has to roll before hitting a barrier is like how much evidence you need to be sure. Complexity, they found, made the slope less steep, meaning the ball rolled slower, and sometimes they even adjusted how high the barrier was. In the situations where options differed in complexity, they found 2 main things explaining why people preferred the simpler one. First, there was a sort of pre-valuation bias. This means before even really digging into the numbers, people already had a slight leaning towards the simpler option. Second, there was a drift rate adjustment. This means that as they were accumulating evidence, they were kind of nudged towards the simpler option during the process. When both options were equally complex, the main story was a reduced signal-to-noise ratio. That means the information they were gathering was just fuzzier. To try and compensate for this fuzziness, they often increased their decision threshold, meaning they waited longer to make sure they had enough evidence. This made them slower and less consistent. Study 2 took a slightly different approach. Instead of changing the number of outcomes, they kept the number the same but made the calculation of each outcome value more complex. For example, instead of just saying 25, they might say 18 plus 26 plus 63, 90 plus 44. It all added up to 25, but it took more mental steps to figure out. And guess what? The results were very similar to study 1. People still preferred the simpler presentation, took longer when complexity was involved, and their choices were less consistent when both options were complex. The modeling also pointed to the same mechanisms. In the complex versus simple choices, that pre-valuation bias and drift rate adjustment were key. When both options were complex, the reduced signal-to-noise ratio and higher decision threshold were again the main explanations. It seems this type of complexity in outcomes also makes our decision-making process slower and noisier. Study 3 then tackled complexity in the probabilities themselves. They used what is called compound probabilities, where you have a 2-stage process to figure out how likely an outcome is. Again, they made sure the overall outcomes and their final probabilities were the same as in the simple lotteries. This is where things got a little different. In the complex versus simple choices, people didn't really show a preference for the simpler option anymore. They chose complex and simple lotteries about equally often, and it took them about the same amount of time. This was a departure from the first two studies. However, when both options were equally complex, they still saw the effects of slower decisions and less consistent choices. And interestingly, in this probability complexity scenario, when all options were complex, people actually showed a stronger preference for certain types of lotteries. Specifically those that were right-skewed, meaning they had a small chance of a big win. The modeling here showed that the pre-valuation bias and drift rate adjustment weren't really showing up at the group level in the complex versus simple choices. This explains why there wasn't that complexity aversion we saw before. But in the equally complex situations, the reduced signal-to-noise ratio was still there, and now a stronger preference for right-skewed options was also clearly identified. So, what does all of this mean? It paints a picture of decision-making as a dynamic process. Not just a static calculation. Complexity isn't just a feature of an option. It actively changes how we process information. When all options are complex, the signal-to-noise ratio reduction is a consistent finding across all types of complexity. It's like our brain just can't filter out the noise as well when things are complicated. The fact that people then adjust their decision threshold suggests they have some awareness of this, trying to compensate for the reduced quality of information by demanding more evidence. When options differ in complexity, the avoidance of the complex option seems to be a combination of starting to favor the simpler one even before deep processing, pre-valuation bias, and then continuing to lean that way during the decision process drift rate adjustment. This suggests we might actively try to avoid cognitively demanding tasks. A really important takeaway is that the type of complexity matters. Complexity in outcomes, like in Study 2, led to similar patterns as complexity in the number of outcomes from Study 1, but complexity in probabilities in Study 3 didn't trigger that same aversion when simple and complex options were compared. Instead, it seemed to make people represent probabilities more fuzzily, which then changed their preferences, especially for skewed lotteries. This is a big deal because it tells us we can't just treat all complexity the same. This research really pushes forward our understanding of decision-making by showing that it is not just about what we value, but how we arrive at that value. The idea that our cognitive resources are limited, and that we adapt our strategies based on those limitations is crucial. It explains why sometimes we prefer simpler, even if less optimal choices. The study also touched on individual differences. They found that while some people consistently avoided complexity, a few actually preferred it. Interestingly, general cognitive abilities like numeracy or intelligence didn't seem to predict how well people handled complexity itself, though they did predict making choices that were more aligned with the best possible outcome. This suggests that other factors like attention or motivation might play a bigger role in why some people struggle with complexity more than others. Of course, no study is perfect. The researchers pointed out they didn't have a single measure for how complex each manipulation felt to participants. This might explain why the effects weren't always the same strength across studies. They also suggest future research should look at choices involving losses, not just gains, because complexity might be perceived differently when there is a risk of losing money. And understanding the role of attention, like where people look when making these complex decisions, could also be a fruitful area. Ultimately, this research gives us a powerful new way to think about decisions under risk. It is not just about rational calculations, it is about how our brains, with their limited capacity, construct preferences dynamically and how we strategically navigate those limitations. It's a reminder that sometimes the best choice isn't just about the outcome, but about how much mental effort it takes to get there. So, next time you're faced with a complicated decision, remember that your brain is working overtime, and it is okay to sometimes lean towards a simpler path. It's not necessarily a sign of weakness, but a sign of your brain trying to manage its resources efficiently. What do you all think about this research? Does it explain some of your own decision-making habits? Let me know in the comments below. And if you found this breakdown helpful, please give this video a thumbs up and subscribe to RUBIN'S Mind Lab for more insights into the fascinating world of psychology. Thanks for watching, and I'll see you in the next one.